Hello viewers, and welcome once again to my YouTube channel. In this video we're going to provide the solution to the sum of these two angles CAE plus BDE. If you look at the diagram very well, you will notice that there are lines connecting BD and E, but we do not have lines connecting CAE. So the first thing we're going to do is to draw lines connecting CA and then E. So the angle CAE we are looking for is the angle here, while the angle BDE we need to find is the angle here. So we are simply to find the sum of these two angles. I will start by finding the angle here first. Can you remember that when you have an X shape, vertically opposite angles are equal? So if the angle here is 50 degrees, we can equally say that the angle here is 50 degrees because vertically opposite angles are equal. Next, when you have a triangle in a circle and the vertex of that triangle touches the tangent, can you remember that angles in alternate segments are equal? The angle here is in alternate segment to this one. They are equal. The angle here is also in alternate segments to this one. They are equal. So if the angle here is 50 degrees, the angle here is equally 50 degrees. Next, if you look at this triangle, it is what? Isosceles, because of these two signs we have there. And for an isosceles triangle, the base angles are what? Equal. So if the angle here is 50 degrees, you can equally say that the angle here is equally 50 degrees. Now the next thing I'm going to do here is to draw a line from here to cut the angle at B. Let's now use this arc to find the angle subtended on the circumference here. If this arc subtends an angle of 50 degrees on the circumference here, the same arc will go on to subtend the same angle of 50 degrees here, because angles in the same segment are what? Equal. So if the angle here is 50 degrees, the angle here is equally 50 degrees. Let's also use this arc to find the angle subtended on the circumference here. This arc subtends an angle of 50 degrees on the circumference here. The same arc will go on to subtend an angle of 50 degrees here, because angles in the same segment are equal. Bear it in mind that we're looking for this angle plus this angle. So how do we get the two of them? In order to solve this question, this angle we are looking for here is the same as the angle here. What is the reason for that? If you look at this arc goes on to subtend this angle on the circumference. The same arc goes on to subtend this unknown angle at the circumference. So the two angles are equal because angles in the same segments are equal. So let's simply find the angle here. It is the same as this one. So let's find the angle here. It will help us to solve the question. Now, in order to find this angle, I am simply going to use this triangle with respect to its exterior angle. Can you remember that the exterior angle to a triangle is equal to the sum of the two opposite interior angles? So now that this angle is the same as this, if we simply add this with this, it is equal to the exterior angle we have here. So now we've gotten one as 50 degrees. Let's get a second angle here. If you now use this triangle, it is what? Isosceles. And for an isosceles triangle, the base angles are what? Equal. So if the angle here is 50 degrees, the angle here is equally 50 degrees. And then using sum of angles in a triangle to be equal to 180 degrees, 50 plus 50 is 100, plus this 50 again, that is 150. So the balance here is going to be 30 degrees. The balance there is 30 degrees. So finally, the solution to our question is actually 80 degrees. The two angles we are to find is this angle plus this angle, and they are the interior opposite angle to this exterior angle here. The exterior angle to a triangle is equal to the sum of the two opposite interior angles. So the two angles we asked to find is simply this plus this, which is equal to these two angles here. So the solution to our question is 80 degrees. Thank you for viewing. For more exciting videos like this, kindly subscribe to my channel and share my videos.